Oh, hi, and welcome to the Daily Space Weather. Congratulations on realizing the channel exists, and welcome to the Smash News Network least busted name in news. Did I hear something about solar flares and coronal mass ejections? I could have sworn I heard something about that on the interwebs in the past about 12 hours. Let's see what's going on there. It looks like a sort of a long-duration solar flare there, as we just bring you the most detailed imagery of the sun and most comprehensive space weather you'll find anywhere in the world. Did it produce any coronal mass ejections? Or would we be better off saying, are there any coronal mass ejections associated with this incredibly awesome flaring event? You're looking at SDO in 304 plus 131 angstroms. And indeed, there were some coronal mass ejections. Are they headed toward Earth? Do you have to lock yourself in a bunker today? Should you go and clean out Walmart from all of their bagged rice? We'll let you know later in the video. Here's the past 24 from SDO. That's 193 plus 304 angstroms, ionized iron, and helium. The ultraviolet emissions, the extreme ultraviolet, the upper end of the electromagnetic spectrum in terms of ultraviolet radiation there. Some exciting activity indeed, plus a new sunspot, which we shouldn't leave out, just rose down here in the southeast. Also, sector boundary crossing is coming, and lots more. We'll get to it. First, yesterday plus today from SDO Intensitygram. So there is our sunspot view yesterday plus today. We've got some growth down here, so that increases the likelihood of a major flare in the southwestern limb. So check it out. That's a huge amount of sunspot growth down there. Also, another large sunspot just rose down here. It's larger than planet Earth. Let's take a look at the magnetic fields for yesterday plus today. Exciting stuff going on in the realm of space weather, and it's only getting better. So let's take a brief look here at croissant Earth. Yeah, Earth, it's croissant shaped. Don't believe all the hype. Earth, it's shaped like the French pastry, the croissant. And let's see what's erupting. Shiveluch is producing a 14,000-foot plume of volcanic ash. Please do not pole vault the caldera. That's a flight level 140 over Kamchatka from Shiveluch. Suminosejima producing a 9,000-foot ash plume. Karengatang producing an 8,000-foot ash plume as it explodes on the Indonesian Isle of Siau. Also, Semeru exploding, flight level 140. That's East Java, Indonesia. Popocatépetl exploding over central Mexico. We've got a 20,000-foot plume of volcanic ash. It's a flight level 200. Flight level 150 over Guatemala from Fuego as Fuego explodes. Also, Sangay moving down to South America in Ecuador exploding. Flight level 220, 22,000-foot ash plume. Revenador, no volcanic ash observed. Don't assume it's not erupting. Cotopaxi is erupting, producing a 21,000-foot ash plume as it explodes. Flight level 210 over Ecuador. And Sabancaya producing a flight level 230 over Peru as it explodes. Please do not pole vault that caldera either. Next, we are looking at the last 90 days of seismicity. That's the convenient 90-day bar graph provided by volcanodiscovery.com. And let's see what's been shaken, bacon, over the past 24 hours here on the USGS site. No major quakes have happened. Quite a few quakes, especially around the Pacific Rim. Did we even see a 5+ magnitude quake in the past 24 hours? Hardly. Not even sure if we have one over 5 magnitude. Just scrolling up the list here, and we do have at least 2 quakes to report on. The 5.1 at Costa Rica. I'm sorry, a 5.2 at Costa Rica. That occurred at 8:24 this morning. That 5.2 at Costa Rica at 8:24 this morning. Drop us a comment if you felt that quake. As I know somebody who was just vacationing in Costa Rica. I'm not sure if he's back yet. Vanuatu saw a 5.3. That was at 9:02 this morning. Only a few minutes after the Costa Rican quake. But on the other side of the Pacific Ocean. So that's it. That's our quake report. No major quakes here, but quite a few smaller quakes. Keep in mind, any earthquake can be a foreshock, and let's get back to space, where the action is at and where our channel has been focused for pushing 6 years, folks. Barely missing a day for space weather. And again, thanks for tuning in and congratulations on realizing the Smash News Network exists. Thanks for leaving a comment, Mr. Bordages. Wait till you see the imagery we've got coming here. It is quite spectacular indeed. There's the last 24 hours in ionized helium from SDO 304 angstroms. One of the classic wavelengths there through which to view the ultraviolet emissions of the solar corona and chromosphere. 10.7 centimeter radial flux is, get this, 343 solar flux units. Yeah, 343. So where does that lie? Well off of this graph. It would be off of my monitor entirely, actually. 343 is the current report, and that's an erroneous number because that radial flux was measured during the flare/coronal mass ejection event of yesterday, and that's why we have such a high number there. So just to give you an idea of how high that would be if that was actually correct, is, well, that would be higher than any of the cycles on the graph here. It's nearly double the radial flux of the graph portrayed here. It only goes to 175, and that would be 200 solar flux units. So that would be like way up here somewhere. If it was actually at 343, it would be way up here, folks. Again, that's an erroneous reading. That reading was taken for this 10.7 centimeter radial flux during a radio burst. So coronal mass ejections regularly cause radio bursts. That's why we see such a high number here. That'll be revised today. It'll probably be something more like, I don't know, 170? 170. That's my guess for the 10.7 centimeter radial flux. Also, we've got NOAA forecasting additional coronal mass ejection impacts here later today, late in the day tomorrow, Sunday, February 19th. Also early in the day on Monday, February 20th. All kinds of CME impacts forecasted there. We'll tell you what we think about it. If you'll notice, we weren't incorrect on our forecasting about last night's forecasted CME impact, since there was none. So there's your KP index. And should I say we told you so? I guess not. But there's your KP index for the past 3 days. It's geomagnetically calm conditions. Here's the past 4 hours of crescent Earth's magnetic moment from space. It's our Geospace Magnetosphere movie, depicting magnetohydrodynamic pressure. Again, things geomagnetically calm here, despite all kinds of forecasts for CMEs to impact, which never arrived. Perhaps they were adsorbed, masked, or otherwise refracted or impacted by the coronal hole high-speed stream, which has subsided over the past 24 hours. Here's the last 4 hours of Earth's magnetic moment from the ground. Facts. Facts are what we cite on the channel. And it's pretty easy to call balls and strikes, folks. If you don't have an agenda, you probably won't destroy your own credibility, never to regain it. Don't destroy your credibility, folks. You'll probably never get it back. If people stop believing you because you're full of you-know-what, if you've painted yourself into a corner, come out of the corner. We don't mind the footprints. Move forward into reality. So here's the real-time solar wind for the past 24 hours. Again, we've seen the subsiding of a coronal hole high-speed stream and not a lot else. So you can see the solar wind, the plasma temperature here dropping down, typical of coronal hole high-speed streams ending, and a reduction in the solar wind velocity. So current conditions are about 450 kilometers per second for the solar wind velocity, solar wind density about 6.5 protons per cubic centimeter. No CME impact yet, and that's exactly what we forecasted. Next, the GOES magnetometers here showing some pretty high readings, some pretty high highs and high lows. Let's show the 7-day graph just to give a little bit more context to that. There's your 7-day GOES magnetometers as measured by the GOES 16 and GOES 18. And next, let's take a look at the heliospheric current sheet. So there could be a magnetic tug-of-war going on over here. We see the sector boundary crossing here getting close to stereo A. So we are currently in the North Pole oriented current sheet. There is a South Pole current sheet which could arrive really at any moment, because keep in mind the magnetic environment can suddenly change, as you may have noticed yesterday. But in any case, at the moment, Earth and stereo A and stereo B, which this is stereo A, by the way. That's stereo A right there. And then stereo B is right here. There is a South Pole current sheet headed this way, and the North Pole current sheet has been impressive with its strong magnetism indeed. Some powerful coronal holes here, and we can expect a coronal hole high-speed stream in about 3 days as well. We'll talk about coronal holes here in a moment. First, our line of sight field plot, because we want to show you the solar B field as well. So there's the solar B field depicted in blue. That's the field that goes through the magnet, this magnet being the sun. Solar polar fields in green for north, red for south. You can see that South Pole current sheet headed this way. Let's take a look at the coronal hole line of sight plot next. There is your coronal hole line of sight plot. And we've got some South Pole oriented coronal holes here making their way in from the east. So let's bring up the latest frame here and we'll label these coronal holes. So we've got South Pole oriented coronal holes all around the east and south, crossing the equator, and we have a well-defined North Pole oriented coronal holes and some other relatively well-defined North Pole coronal holes here rotating out. So this is South Pole. So this one's North Pole. This one's South Pole. And again, we can expect a significant coronal hole high-speed stream from this one, because that's still a highly well-defined coronal hole there. And let's move to sunspots. As we do have at least one new large sunspot here rising in the south. So that's 3230. Sunspot 3230 will get a name today. Also, again, we've seen some major growth of this sunspot group down here. That's 3228, I believe it is. So the likelihood of major flares, I'd say, is very likely right there, the southwestern limb. As that sunspot has rapidly grown, and as it approaches the limb, it is, of course, more likely to produce major flares. So here you'll see that growth happening in the southwest. And thanks for leaving comments, Mr. Katowski. So there's the past 24 hours from SDO intensitygram. We've got some major sunspot groups here that could produce some major flares. So don't be surprised to see additional major solar flaring, and let's get to that. First, the relativistic particles. So we don't have any here showing up as measured by the GOES 16. So no relativistic particles showing up at Earth despite that long duration X-class flare. So here's a great image of it. Let's we'll actually bring up the one-day graph here just to show you how long of a duration that was. It didn't go down to M-class range until right exactly at midnight, practically. Peak flux there was X2.2, X2.26, and peak flux was around 1800. So we've got some fantastic videos from about 1930 until midnight. And yeah, you will not be disappointed by the footage to come here. So yeah, that was a major flare there, and it was of extremely long duration. It did cause some relativistic particles likely to hit stereo A, which we will show you here as well. So that's your GOES X-ray flux for the past 3 days. And I'll bet you'd like to see some close-up imagery of those solar flare events, wouldn't you? Well, take a moment to support the channel first. The official subscription services site of the Smash Team is smashomash.com/SmashTeam. You can find links below the video, as well as on the homepage at smashomash.com. So click the links down below the video. Hit us up on Instagram. Maybe join us on Discord. We've got a permanent invite link to the Discord chat. You can also find our Patreon, Facebook, Twitter, YouTube channel, a link to the Hemp Lucid site. Make sure you save some cash by entering the promo code SMASHOMASH10 on your Hemp Lucid orders. Join at the gold or silver level to get additional content and to help support the channel and continue to increase the probability these videos will remain in existence, publicly visible and free for all to view. Click post to see the latest. Make sure you're logged in. Links to the Smasho forum and the merch site and so on, all there on the page. You can also support the channel with today's featured product, which is Do Not Pole Vault the Caldera. Please don't pole vault the Caldera, folks. If you're going through hell, keep going. Our finest days lie ahead, and while things are certainly able to get much worse, especially based on terrible decisions made by terrible decision makers, our finest days lie ahead. So thanks for leaving comments to our other Twitch commenters. We appreciate that. And whatever you do, please do not pole vault the Caldera. If you're going on a volcanic vacation, if you're a volcanic sightseer, leave that vault pole at home. And don't pole vault the Caldera. This public service message brought to you at massive personal risk and expense by Smash staff and I, so give Smash staff a raise by picking up some merch. If you click the link below the video, you'll find our products in order of best selling. Do Not Pole Vault the Caldera is our best seller, thanks to everybody who's picked up merch, because reasons. So here's the past 24 hours in 94 angstroms from SDO. And yeah, that isn't even the money shot. That is one of the money shots. That's 94 plus 131 angstroms, only for the time associated with that flare. And don't worry, we're going to get a lot more close and personal than that. So there's just 131 angstroms by itself. Yowzers. That was indeed a spectacular event. Here we've added 171 angstroms. So this is 131 plus 171. And we've slowed this down to 10 frames per second there. We usually show 30 frames per second. That's only 10 frames to show you maximum detail. What, that's not close enough? Okay, how about this? Is that good enough for you, folks? Is that good enough solar imagery? Have you pressed like yet? By the way, if we see 50 likes, we will stream live on YouTube. If you're viewing the content on BitChute, make sure you subscribe to the YouTube channel, as you're missing most of the content. Here's 131 plus 94 angstroms. The same frame rate and time frame. That is from 1930 to 2359 yesterday. And keep in mind, it was still flaring at that point, but it dropped down below an M-class level right at midnight. So that's why we ended the slow-mo there. Here's some more slow-mo. This is 1600 angstroms plus 193. 1600 angstroms represents the ultraviolet emissions of ionized carbon. So, interestingly enough, some nuclear fusion likely happening there. Where do you think all that carbon came from? Well, it was built. That carbon was built right there before your very eyes. So here's a closer view of that same region. 193 angstroms is ionized iron. 1600 angstroms ionized carbon. You can see that brightening there. And that, my friends and foes, is some killer imagery. We've also included just 1600 angstroms alone. So all those white areas, those are areas that are extremely rich in ionized carbon. The dark areas are areas that are largely devoid of ionized carbon. You see a lot of carbon showing up here sort of at the beginning of the flare. We'll let that play through one more time. And if you'd like a brand new carbon bike, that's probably enough carbon to build one. Don't worry, folks, carbon bicycles are going to get a lot less expensive. All right, so let's move on here. This is a star chart of what's going on over our head in Lehigh Valley right now. That's from skyandtelescope.org. You've got the sun chasing Saturn and Mercury there across the ecliptic. Also, you've got the moon in a crescent waning state there. A great frame featuring the sun, the moon, Mercury, and Saturn all at once. If you're up before dawn, you might see that. Saturn rising just ahead of the sun there. That's your star chart for Lehigh Valley, Pennsylvania, from when we streamed the video. Keep in mind, most of our data sets do include time and date stamps. So here's your forecast for the solar system, heavenly bodies, and you're probably wondering if the sun has sent a CME in that direction. Don't worry. We'll hook you up with the information to make informed decisions. First, a solar system forecast. This is where heavenly bodies are today. There's where they'll be in 1 week on the 25th. We will have a crescent waxing moon by then. And let's take a look at some coronagraphs, as they've got some spectacular imagery indeed. There's one CME. And that's just yesterday's frames. Let's take a look at today's frames. And today's frames are a little bit more exciting there, as there are some major CMEs there in the southeast. One other thing I'd like to show you real quick is the view from Stereo A for today. Check it out. We've got one frame. And Stereo A got pummeled by relativistic particles. So that solar flare did indeed find itself associated with some relativistic particles. And some of those likely struck Stereo A. Hopefully it didn't do any damage. Let's move on to some additional coronagraph imagery. We'll show some custom images from Stereo A, which is only about 10 degrees behind Earth right now. It's actually not at Lagrange 5. Thanks for correcting us on that, Dr. Keith Strong. Make sure you follow Dr. Keith Strong on Twitter. Anyway, that's the location. This is the Where is Stereo A website. It also shows you the location of Stereo B. Stereo A is this red sphere right here. It's just behind the Earth, orbitally speaking, and it sees solar activity just ahead of the Earth. So there's the first CME. You can see it is clearly off on the opposite side of the sun. Let's break this down here. So there's the first CME. Well, let me bring that back. So there's this little CME here. That's on the opposite side of the sun there. That's around 1700. So that's one event. That is an isolated event that is by itself and unassociated with these other major events. And then at about 2100, you can see most of that ejecta here is on the opposite side of the sun. So keep in mind, Earth would be off on this line from the perspective of Stereo A, and Earth would be behind you from the perspective of Soho-Lascaux C3, as that is located at Lagrangian point 1, which puts it about 1 million miles in between the Earth and Sun, someplace around here. That's where Lagrange 1 is located. So now you can see most of this ejecta is certainly well off to the northwest, and it is on the opposite side of the sun. So the majority of the ejecta certainly will miss the Earth. Now we do see a little bit of a halo there from the perspective of Stereo A. So there is a tiny amount of ejecta that may be moving down the Earth line, because you can see a little bit of diffuse ejecta right in this area. So once again, if that is an earthly impact, it'll be very minor, perhaps even undetectable. It may look like a halo, and it doesn't really look like a halo. So I suspect a tiny portion of this is earthly directed. Keep in mind there is also a second event there. So that's 5:06 this morning. And unfortunately, that one is largely missing. So at 5:06, there was a second event that was off to the southeast. And I'm basically doing this analysis right now, folks, so just bear with me here. I'm trying to figure out all of these CMEs. So again, this one may have an earthly component, and you can clearly see here that most of the ejecta is well off on the opposite side of the sun, and that can often create a false halo. So I would suspect there is a small earthly component there. We can expect that to arrive late in the day on the 20th, early in the day on the 21st, if there is even a signal to measure. If so, it'll be very minor because it's very diffuse. You can see how diffuse the outer shells of that are. It's only a small plasma wave there, likely headed at the Earth. Most of that ejecta will certainly miss planet Earth. Let's just bring these back and let them play through, and then we'll show you our custom 24-hour videos. Keep in mind the time and date stamps are listed there on the lower left. So they're not exactly synced. You can see this morning's CME on the right, and a little bit of missing data there on the left. So stereo A did look like it got hit by some relativistic particles, and there is the past 24 hours. So when we zoom in a little bit, it might help us a little bit more to determine if that CME associated with the X-class flare is earthly directed. Again, keep in mind most of the ejecta is on the opposite side of the sun and well off to the northwest also. The second one from this morning, that is not earthly directed. That's well off to the southeast, much like the one that NOAA forecasted to strike Earth last night, which never arrived, or at least hasn't yet arrived. And here's a little closer zoom in. Yeah, I'm not convinced that that's a major CME impact for Earth. It might be a minor CME impact, and it might be another nothing burger, folks. So, yeah, that's the situation. If anybody's telling you to buy one of their bunkers and make sure you lock yourself in it because we're going to have a Walking Dead situation on planet Earth, it's just not going to happen, folks. It's not going to create any kind of a major grid down situation or anything like that. It's just largely a spectacular light show, perfect for channels like ours. All right, so let's continue on here. We've got plenty more things to cover, like filaments. So the likelihood of additional coronal mass ejections is nearly 100%. So we've got major filaments here, and we've been naming filaments on Twitter. If you'd like to name filaments, feel free to do so. Join us over on Elon Musk's shadow banning specialty platform, twitter.com/smashomash. And we've got major filaments here. I've lost track. I think Nay wanted to name one Bruce Willis yesterday because Bruce Willis is in the news, I suppose. So let's just bring up the latest image here. And once again, invite you to name that filament. Did you know we did a Twitter Spaces yesterday? Yeah, we did a Twitter Spaces for about 1 hour at 4 p.m. yesterday. If you don't follow us on Twitter, you wouldn't know about it or be able to see it. So check that out. Also, if you'd like some free samples of Hemp Lucid's mushroom gummies, you can find the link to that on the Twitter page. Save some cash by entering the promo code SMASHOMASH10 on your Hemp Lucid orders, or just use our convenient link right below this video for your Hemp Lucid purchases. Thanks to everybody who's been helping out the channel with that, and thanks to Hemp Lucid. What a spectacularly great affiliate/sponsor. So thanks to everybody for that. Again, the likelihood of additional coronal mass ejections, nearly 100%. We've got dozens of filaments on the Earth-facing portion of the solar disk. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, at least 16, 17 filaments facing the Earth at the moment. So don't be surprised to see properly earthly directed coronal mass ejections. And again, don't forget to visit our links below the video. Save some cash by using promo code SMASHOMASH10 on checkout. Link to the free Hemp Lucid mushroom gummies available there, pinned to the top of the Twitter profile. Here's the past 24 hours in our house favorite wavelength, 171 angstroms. And let's take a look at some more recent activity here from the GOES 16 SUVI. It's what we choose to regularly stream to Twitch. So that's a reason to tune into the Twitch channel if you haven't. And thanks again to our viewers who are viewing this video as it was streamed live at twitch.tv/smashomash. Look for more exclusive content coming to the channel soon. This is the past 24 hours. This is the past about 2.5 hours from the GOES 16 SUVi. And we do see some brightening here. Again, keep an eye on this area as well, as it has rapidly grown. You can see this new sunspot down here. That'll be 3230. And this brings us to our bonus feature segment. So the first bonus feature is our satellites community dashboard. At the moment, no charging hazards here. It's smooth sailing for satellites. Next, the GOES electron flux, as measured by the GOES 16 and GOES 18 from their geosynchronous orbits using radiography to measure the relativistic electron flux at the F layer of the ionosphere, which we will also show an animation of. There's the NOAA forecast for electron flux, and I would tend to agree with that. A little uptick expected in the coming days. There's the one-year graph to put it in context. We've seen very low levels of electron flux, as we typically do see with coronal hole high-speed streams. So there's the coronal hole high-speed stream, a great signature of that, represented in the GOES electron flux. And here is your F layer. Feel free to pause the video on this frame if you're not familiar with things like the penetration of electromagnetic radiation, thermospheric temperatures, and molecular densities. Here is the animation, courtesy of Australian Government Bureau of Meteorology, of the ionosphere itself. So that's one slice of the atmosphere, folks, the upper layer of the thermosphere known as the F layer. It's in many ways the bridge between Earth and space, and we're showing the vibrational frequency here in megahertz. That's millions of vibrations per second. And frankly, it looks like we're seeing some major low-frequency anomalies here. So we'll let this play through, and then we'll show you the anomalygram, which I'm sure will show a lot of red. So there's your anomalygram showing anomaly in megahertz from a 30-day median. Don't worry, folks, the sun's not going to kill you. However, terrible decisions by humans might. There's the latest image of the ionosphere. That's 1330 Universal Time ionogram and 1330 Universal Time anomalygram. Shifting to high-frequency anomalies here, right around the equator. And a great example of where the South Atlantic anomaly is right here, back to where it was over the South American continent. Continuing on to show the total electron content, that's the free electrons between your GPS satellite and your handset. Feel free to pause the video on this image if you're not familiar with distances of things like the Van Allen probes, the Van Allen belts, etc. Here is your total electron content forecast, which is getting much less anomalous. So this is a lot more normal than it was. You can expect to see GPS errors where you see those red areas, and we're seeing a lot more organized total electron contents, more of what we're accustomed to seeing. So much lower levels of GPS errors here, and you can expect this to get even more clean. So your GPS should be working better in most locations, of course, besides around the equator at noontime. The total electron content here looking less anomalously than it's been for the past few months, frankly. See our previous daily space weather videos every day for details on that. Next, we'll close out the space weather section of the video with our latest intensitygram and latest colorized magnetogram. So let's first take a look at this new sunspot down here. Looking like it's alpha class so far, meaning only one magnetic field polarity. There you go. It is a South Pole umbra with no other umbrae there. So the likelihood of it producing major flares not very high. The likelihood of this sunspot producing major flares, well, it's beta gamma class. And it could be turning into beta gamma delta class. We do see some field complexity there. Let's show the umbrae as well. There you go. It's beta gamma class, but it has grown significantly since yesterday. So once again, keep in mind the magnetic environment can suddenly change. And of course, let's take a look at this suspect up here. It's got a light bridge going across it. You can see some plasma there crossing the umbral central region of that umbra there. And we call that a light bridge. It is beta gamma delta class, so it's certainly capable of producing large flares. Here's your full disk rock back before we move to meteorology. So let's blast through some meteorology here, and we're going to start out things by looking at carbon dioxide. So let's take a look at carbon dioxide here, and it looks like the largest, the highest concentrations of carbon dioxide that I can find on this map are located up here in Siberia. You're probably thinking, wow, it must be really hot up there, right? Look at 471 parts per million, folks. That's pretty high carbon dioxide, right? Let's check the temperature. Since carbon dioxide is such a potent greenhouse gas, allegedly, let's just check the temperature. So, okay, so there we go. That's same location there. What do we got? Temperature. And it's, it is 41.5 degrees there. All right. Case closed. Case closed. It's warm in Siberia because of carbon dioxide. All right. Hopefully we didn't offend you too much with that little sarcastic aside. Let's take a look at the wind patterns around planet Earth to close this video out and get it onto your screens. So there is our surface wind scenario for the eastern world. Here is the jet stream scenario for this side of the planet. Of course, we still have this huge S over the Western Pacific, which everybody knows stands for Satan. Whenever there's a letter on a map, it's, of course, very scary. So that's something to be frightened of. If you're not frightened of space weather, you could be frightened of the jet streams forming an equatorial S over the Western Pacific and Oceania. I'm spooked. Are you spooked? Hopefully we've spooked you. These are the jet streams of the Western world. Facts. These are the surface winds of the Western world. Strong low there off the southeastern coast of South America. Here are the surface winds of the central world, and these are the jet streams. And let's move on to our clouds and fog. There you can see the day-night terminator there rising over South America and the Atlantic. That is 3.9 nanometer infrared radiation. It shows clouds and fog. It's too dark to use the visible satellite. So if you want to see what's going on with clouds and fog at nighttime, check out the NASA GOES Interactive Weather Satellite Suite 3.9 nanometer shortwave radiation map. We'll show you the radiation emitted by clouds and fog. Water. It is a very potent greenhouse gas. That's why it stays warm when it's cloudy at nighttime, folks. Yeah. Water vapor is why, and clouds, of course. Water vapor that's condensed onto clouds is why it stays warm at nighttime. Anyway, here's your weather.gov map. We've got some severe weather warnings there on the big island of Hawaii, some flash flood warnings. If your location's lit, click your location. We briefly scrolled down to show you the key, and there's some flooding there forecasted for the southeastern U.S. Weather.gov is your location for that. Let's do some forecasts here. This is the 72-hour GFS temperature anomaly forecast. Keep in mind that is in degrees Celsius. Again, that's your 72-hour GFS temperature anomaly forecast. We'll also show the 72-hour pressure and precipitation forecast because we like our forecasts to be accurate. So we don't show like 3-week forecasts like some silly channels and try to put up alarmist weather maps that never come true. That's a 3-day forecast or 72 hours, which is very likely to be correct. Some heavy precipitation there coming once again to Washington. Also the northern Rockies. We'll see some continued snow, so let's do a snow forecast as well. There is your GFS 72-hour positive snow depth change in inches. That brings us to our windy.com map. We'll just show the difference between the GFS and the Euro forecast. That's the next 3 days on the Euro model. And there is the next 3 days on the GFS model. The Euro model predicting some major snowfall there in Mexico. GFS model, not so much. Just a dusting, it looks like. Again, that's your European 3-day forecast for new snow. And there is your GFS forecast for new snow. We'll also show your NASA Goes Lightning Mapper as we do most days. So there we've got some lightning off the coast of North Carolina and so on. And here's your current lightning map, a real-time lightning map from lightningmaps.org. Next time you hear thunder, check it out. You may be able to convince the natives that you're Zeus or something like that. Perhaps portray a horror movie villain by forecasting thunder. Say something scary just before thunder rolls in and freak people out. SmashOmash.com is the official homepage of the channel. So make sure you check out the homepage if you haven't before. Assist the channel with clicks. Yeah, click-through rate, it matters. Most importantly, press the like button. Again, if we see 50 likes on today's video on today's calendar date, we will stream live to YouTube, despite the pathetic, putrid, and disgusting censorship on the platform. Now, yesterday we were streaming live to Twitch when the major solar flare event happened. And that's what you would have seen if you would have been subscribed to the Twitch channel. Splentacular imagery there from the Agos 16 SUVi. And we stream it regularly so that we catch all the footage. That was a good time. Twitch.tv/SmashOmash is the main live streaming channel of the Smash News Network. Least busted name in news. Make sure you press like and subscribe. Tell your friends and foes about us. Please press the share button, as we are unconvinced that YouTube recommends the content. Pretty sure we're shadow banned on literally every, quote, social media and, quote, website in the known universe, including alt tech. Check our playlists to see videos that are unrelated to space weather. Have you heard the 12 Days of Smashmas? Blast that in your car if you haven't. The 12 Days of Smashmas, starting out with Blacksmith. You can find us all over the internet at Golden Cap Productions. You can find the Golden Cap Productions record label on Spotify, on YouTube, Amazon Music, YouTube Music, all over the place. It's on iTunes. There's like over a dozen different locations where you can listen to Golden Cap Productions original tracks. Blast them, as they are highly produced. Anyway, here's your latest real-time imagery here. That's your U.S. Doppler radar for the full 50-state view. Some precipitation there in both Alaska and Hawaii. There's Alaska. We'll zoom in on Hawaii briefly. Some quite heavy precipitation there, especially around the Big Island. And we'll focus on the lower 48. Some precipitation there in Texas and New Mexico, also in the Pacific Northwest, and a little bit of activity there in upstate New York. Albany seeing some snow showers likely. Here is your clouds and fog view, 3.9 nanometer radiation over the lower 48. A bunch of low clouds there over the eastern seaboard as well as the Gulf. A great example here, you can actually see winds accelerating here. Right there, you can see winds kind of blowing north to south off the coast of Jersey and so on. That's helping to form those low clouds. And here is your water vapor map. Some cooler air here pushing into Pennsylvania today. It's a little bit more seasonable for February 18th. We'll close things out with a recap. U.S. Doppler radar map. Shortwave radiation showing clouds and fog. And water vapor. And thanks again for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. SmashOmash, signing off. And may that solar wind be at your back.